Hello friends, in this video we are going to study the various components of cathode ray oscilloscope or CR. So let us start with that topic. The cathode ray oscilloscope, also known as CRO, is one of the prerequisites of any electronics laboratory. In any electronics or electrical laboratory, we are going to see this CRO, or it is a must present instrument in these laboratories. Now, this CRO, it is one of the most flexible, versatile and adaptable instrument which is used for the display, measurement and analysis of various types of waveforms. So the CRO, it is basically used to display, measure and analyze the various types of waveforms and other phenomena in the electrical and electronic circuits. The CRO, we can say that it is a test instrument which allows an individual to plot a signal on the XY plot. Like on X-axis we will have the time and on Y-axis we will have the input signal. So the CRO, it allows an individual to plot the signal with respect to time or with respect to another signal. So the CRO, it is plotting also, and it allows the individual to view also the two-dimensional graphs, because we are plotting the signal on an XY axis. So on X-axis we will have the time and Y-axis we will have the input signal. So we are getting a 2D graph of the electronic signals. Now these electronic signals, they can be voltages, they can be current, strain, acceleration, pressure or any type of electronic signal. Now the CROs, they basically operate on the voltages. So if we want to plot the current, acceleration, pressure or the strain, we have to convert them into the voltages with the help of transducers, and then we are going to plot these signals with respect to time or with respect to a voltage. So we can say that CRO, it is a XY plotter which is plotting the signals on the X-axis and the Y-axis. Okay. Now here we are going to study the various components of a basic CRO circuit. Now if we talk about a normal CRO, then the various components of a CRO are: first is the cathode ray tube, whose short form is CRT. Okay. Second is vertical amplifier. Third is delay line. So these are the 7 various components of the cathode ray oscilloscope. First is the CRT, that is cathode ray tube. Then we have the vertical amplifier, delay line, horizontal amplifier, time-based generator, triggering circuit and power supply. If we see the block diagram of these various components, then this is how the components are represented in the form of blocks. We are having the vertical amplifier, delay line, then we have the cathode ray tube. This whole section is the cathode ray tube or CRT. Then we are having the power supply section, triggering circuit, time-based generator and horizontal amplifier. Now let us study the function of these components one by one. First we will start with the cathode ray tube. The cathode ray tube or CRT, it is the main part of CRO, and that is why it is known as the heart of CRO. So why the CRT or cathode ray tube, it is known as the heart of CRO? Because the CRO, which is displaying the input signal, that main display part is done through the CRT. Now what the CRT is? CRT is a vacuum sealed glass envelope, and in that glass envelope there is a source of electrons which is producing a beam of electrons, and these beam of electrons, they are accelerated at a very high speed, and then these electrons pass through two pairs of plates before striking a phosphor coated screen. And when this beam of electrons strikes the phosphor screen, it is going to produce a luminous spot, and it is going to display the signal, the input signal, on the display area. So the main part of displaying the waveform is done by the CRT. That is why it is known as the heart of the CRO. So if we see that the CRO, what it is having, it is a vacuum sealed glass envelope, and it is having a source of electrons which is emitting the electrons, and these electrons are accelerated to pass through two pairs of plates before striking a phosphor coated screen. So if we talk about the various parts of CRT, it will have first the glass envelope or the source of electrons, the two pairs of plates, and a phosphor screen. So let us study the various parts of the CRT. If we come to the block diagram again, you can see here that in the CRT we are having this glass envelope, and in this glass envelope we are having an electron gun which is producing the beam of electrons passing through two pairs of plates. One is the vertical deflection plates and second is the horizontal deflection plates, and then this beam of electrons is striking the phosphor screen. Okay, so if we come to the various the parts of CRT, first we will have the electron gun, then we have the deflection plate system, then we have the phosphor screen, or we can say the fluorescent screen, we will have a glass envelope and a base. So these are the various parts of the cathode ray tube. Now coming to these parts, First, we will have the electron gun. The electron gun, it is the source of the electrons, and it is going to produce an accelerated, energized and focused beam of electrons. If we come to the internal structure of the cathode ray tube, which is consisting of the various parts, electron gun, the glass envelope, the deflection plate system, then the internal structure of the CRT will look like this. Okay, in this you can see we are having a base. Okay, then we are having the electron gun. This is our glass envelope. Then we are having a phosphor screen. Okay, so and we are having the plate system also, the vertical deflection plates and the horizontal deflection plates. Now if we come to the electron gun, then electron gun also consists of some parts. It will have the heater, the cathode, the control grid, pre-accelerating anode, focusing anode and the accelerating anode. So if we come to the parts of electron gun, first part is the heater. Now what the heater does, the heater is going to heat the cathode, and when the cathode is heated, it is going to produce a beam of electrons. So the function of heater is to heat the cathode. You can see in the diagram, this is the electron gun. First part is the heater, then we are having the cathode. Now the function of cathode is to obtain these because when the cathode is heated, it is going to release the electrons through it. So cathode is generating the electrons. Now how the electrons are generated? This cathode, it is coated with a layer of barium oxide. And when this, because the cathode, it is coated with a layer of barium oxide, so when this cathode is heated through this heater, it is going to release the valence electrons of the barium oxide. It is going to split and the electrons will be generated. Okay, so that is the function of the cathode. Now when these cathodes are generated, because we want that we should get a focused beam of electrons. Here we have studied that the electron gun, it generates an energized and focused beam of electrons. So the electrons which are moving here and there, these electrons, they will be focused, and the focused beam of electrons will be generated through the control grid. You can see that when these electrons, they pass through a very small hole, then it is going to produce a beam of electrons. Okay, so what is the function of the control grid? And it controls the number of electrons, because control grid is having a very small in it. So how many numbers of electrons are passing through it, that will be, if we are making more space in that control grid, more number of electrons can pass through it. If we minimize the distance between the control grid, then the number of electrons will be less. So we can say that the intensity of the display, that will be managed, or that will be controlled through this control grid. Now after the control grid, we have the three types of anodes in the electron gun: pre-accelerating anode and accelerating anode. Then we have the focusing anode. So what is the function of these three anodes? So the pre-accelerating and the accelerating anode, they are going to accelerate the electron, and these anodes are connected to a common positive potential of 1500 volts. So after coming out of the control grid, the electrons, they pass through these two anodes and then they are accelerated. After that we have the focusing anode. The function of focusing anode is to focus the beam of the electrons, and this is connected to an adjustable voltage of 500 volts. So we can see that in the electron gun we have having the different parts, like heater was there which is heating the cathode. Cathode is used, cathode, it is layered with it is having a layer of barium oxide, and when this cathode is heated, it is going to produce the electrons. These electrons are then passing through the grid, which is controlling the number of electrons which are passed further. Then these electrons, they pass through the pre-accelerating and the accelerating anode, which are going to accelerate the electrons, and then these electrons are focused using the focusing anode. So you can see that the beam of electron which is coming out of the electron gun assembly, it is a beam of very sharply focused, accelerated and energized electrons. Okay, because these electrons, they are, because when they are passing through the control grid, it has been converted into a beam which is striking on the phosphor screen. Okay, so it has been converted into a beam which is having a very high speed, and focused beam is there. So this was about the electron gun. Now this sharply focused accelerated electrons, they are now going to pass through the deflection plate system. This deflection plate system, it consists of two plates: vertical deflection plates and horizontal deflection plates. So let's study about this deflection system. So as I have said that the deflection system, it consists of two pair of plates, horizontal plates and vertical plates. So the plates which is causing the electrons to move in the horizontal direction, they will be called as the horizontal plates, that is the X plates, because they are causing the electrons to move in the X axis or in the X direction, that is from left to right. Now the pair of plates which is causing the electrons to move from up and down, okay, in the vertical direction, they will be called the vertical plates, or we can say Y plates, because in the upward direction or in the vertical direction, they are causing the movement of the electrons. So horizontal plates are also known as the X plates, and vertical plates are also known as the Y plates. So in a CRO, we are having two pair of plates, that is horizontal plates, we can say Y, Y1, Y1, and we are having the horizontal plates X1 and X1. Okay, now there is a type of CRO which is known as the dual trace CRO. So in the dual trace CRO, two signals are plotted with respect to time. So in that case, we will be having two Y plates, okay, that is two vertical plates and one horizontal plate, that is X1, X1, okay. So through this dual trace CRO, two signals, they will be plotted with respect to time. So that is the deflection system. Now coming back to the block diagram where all the components are represented, you can see that here we have studied about the cathode ray tube, in which we have studied about the electron gun. After the beam of electrons, after coming out through this electron gun assembly, it is passing through this vertical deflection plate system and horizontal deflection plate system. After that, it is going to strike over the screen. Now this screen, it is a phosphorus screen, okay, which is coated with an aqua dag. So when this beam of electrons strikes over this phosphorus screen, it is going to produce a fluorescent, or we can say luminescence is produced. Okay, so due to that luminescence, a spot is produced on the screen, and this spot is going to move according to the deflections caused in the beam of electron due to the vertical and the horizontal deflection plate system. Because when this electron passes through this plate system, it is going to deflect, okay, and it is going to deflect and strike over this screen. So this deflection is according to the input signal which is provided, because this input signal is provided to the vertical deflection system also and to this horizontal deflection system also. So according to the changes in the input signal, the beam of electrons will be deflected over the phosphorus screen. So if we talk about the screen, okay, and this phenomena that of emitting the visible light when electron beam are striking over it, this phenomena is known as the fluorescence. Okay, now this fluorescence, that is the intensity of this fluorescence, it depends upon some factors like physical characteristics of the phosphor, number of electrons bombarding with the screen, means the number of electrons which are striking the screen. If there are more number of electrons, then the intensity of the luminous spot which is produced on the screen, that will be more. Okay, and on the panel of the CRO also we are having a control which is known as the intensity control, which is used to change the intensity of the luminous spot. So that was the screen part. Now again coming to the diagram, this was the cathode ray tube. Okay, the parts which we have studied up till now, these were constituting the cathode ray tube. We studied that the cathode ray tube, it consists of the electron gun, the deflection system, and the phosphorus screen and the glass envelope. Now coming out to this horizontal deflection system and vertical deflection system. The vertical deflection system, it consists of two parts, vertical amplifier and delay line, and the horizontal deflection system, it consists of the triggering circuit, time-based generator and horizontal amplifier. So we can say that this is our vertical deflection system and this is our horizontal deflection system. Okay, so let's study these two systems here. In the horizontal deflection system, the first part is the triggering circuit. Okay, you can see in the diagram that the first component here is the triggering circuit. Now this triggering circuit, it is a link between the vertical deflection system and the horizontal deflection system. You know that in the vertical deflection system or the vertical input, it is our signal which we want to observe, or it is our input signal, and the horizontal input, it is an internally generated ramp voltage. Okay, so this triggering circuit, it is a link between these two, vertical input and the horizontal input. And the main function of this triggering circuit is that both the vertical input and the horizontal input, they are generated at the same time. Okay, so this triggering circuit, it synchronizes the horizontal deflection of the electron beam with the vertical deflection of the electron beam, so that both these deflections, they are produced at the same time. There is no delay in these two deflections. Okay, so we can say that basic function of this triggering circuit is to ensure that the generation of the horizontal and the vertical input, they start at the same time. Now the next part of the horizontal deflection system is the time-based generator. This time-based generator, it is going to generate the ramp voltage, the internal ramp voltage, which is provided as the horizontal input to the CRO. Because we know that in the CRO, two signals means the signal, the input signal, it is plotted with respect to time. Okay, so it is having two inputs, vertical input, horizontal input. Vertical input is the input signal which we want to analyze or visualize, so that is provided to the vertical amplifier and the vertical deflection plates. Then we are having the second input, that is the horizontal input, which is an internally generated ramp voltage. So that ramp voltage is generated through this time based generator. So this time-based generator not only generates the ramp voltage, but it also controls the rate with which the electron beam, it is scanned across the face of the screen of CRT. So what is the intensity, that is also controlled through this time-based generator, that how the electron beam, it is going to strike the phosphor screen. Now, next part of this deflection system is the horizontal amplifier, which is going to amplify the horizontal input without modifying the signal. So its function is just to amplify that signal. Now, this horizontal input is then provided to the horizontal deflection plates. Now, next coming to the vertical deflection system. The vertical deflection system, it also consists of the vertical amplifier, which is going to amplify the vertical input, and also it consists of the delay line. So this vertical deflection system, it is consisting of the amplifier, which is going to amplify small voltages, because to the vertical deflection system or to this vertical amplifier we are providing the input signal which we want to display over this phosphorus screen. Okay, so this input signal, if it is a very small voltage, so it will be amplified through this vertical amplifier, and the CRO is going to measure even the small changes in the vertical input. Okay, now as it is amplifying the signal, so it is not going to, it is just only going to amplify the signal, not the noise part. Okay, so this vertical amplifier, it is a high class amplifier which is having a very high gain. So both these vertical amplifier and horizontal amplifier, they are used to amplify the vertical and the horizontal inputs. Another part of this vertical deflection system was the delay line. This delay line, it is connected in series with the vertical amplifier, and this delay line, it introduces a delay in the signal, that is in the input signal, so that this vertical input, that is our input signal, it is delayed, and both the horizontal input and vertical input, they are synchronized. Okay, so to introduce a delay in the signal, this delay line is used. It is connected in series with the amplifier. So you can see that the input signal, it is first connected to the vertical amplifier. This input signal is provided to the delay line also and to the triggering circuit also. So the triggering of this horizontal input, it is also started by the input signal. Here also we are having the input signal. So this input signal, it is going to trigger the horizontal input, so that this time based generator, or we can say it is also known as the sweep generator, it is going to generate the horizontal input, and then it is applied to the horizontal amplifier. So here I have written that the horizontal time base, horizontal input, it is triggered by a portion of the input signal that starts the sweep generator, or we can say the sawtooth generator, or the time based generator. The output of this generator is then fetched to the horizontal amplifier. Now here this input signal is also applied to the delay line. Okay, so this delay line, it is going to produce the delay in the signal. So we can say here that the signal processing is done. So in order to ensure that this horizontal input and the vertical input, they start at the same time. So that is the function of the delay line. So that completes the vertical deflection system. Now we are left with the power supply section. In the power supply section, you can see that there are two built-in power supply. One is the low voltage supply and another is the high voltage supply. So in CRO, we are having two power supply, that is low voltage supply and high voltage supply. The low voltage supply, it is a supply of plus 300 volts to plus 400 volts. Whereas this high voltage supply, it is from minus 1000 volts to minus 1500 volts. So you can see that the low voltage supply, it is a positive supply, whereas the high voltage supply, it is a negative supply. So this low voltage supply, it is provided to the other parts of the CRO, and high voltage supply, it is provided to the CRT. Okay, so all the other parts of CRO, they will get the low voltage supply, that is the positive supply, whereas the CRT, it is going to get the negative voltage supply or high voltage supply. So that completes the components of the cathode ray oscilloscope or CRO. Let us summarize that what we have studied. First, we studied that there are various components like the cathode ray tube, vertical deflection system, horizontal deflection system, triggering circuit, time-based generator, delay line, and the power supply. Okay. Then we studied that the cathode ray tube, it is the main part of the CRO, also known as the heart of CRO, because it is the part which is generating the electron beam, which is striking the phosphorus screen and producing the signal, okay, displaying the signal. That is done in the CRT. CRT consists of the electron gun, the deflection plate system, phosphorus screen, and the glass envelope. Further, we also studied in detail about the various parts of the electron gun, in which we studied the heater, cathode, the three types of anodes, accelerating, pre-accelerating, and focusing anode, and we studied the control grid and the part. Then the electron beam, it passes through the plate system, then it is focused on the screen. Okay, after that we studied the two deflection system, horizontal deflection system and vertical deflection system, and in the last we studied the power supply section of the CRO. So that completes the various components of the cathode ray oscilloscope or the CRO. So I hope that this topic is now clear to you. Thank you.